Hello and welcome back. This is the last installation I'll be doing in this series on hashing for now, and it covers the last main concept we need to understand to go through understanding blockchains. Along the way to here, I have mentioned a few concepts like confusion and diffusion, and also reversibility and collisions. Now I want to take a moment to bring them all together and explain some basic concepts around cryptographic hashing in particular. However, before I do that, I just want to make a point again that I've made before, which is that encryption and cryptographic hashing are not the same thing. Encryption is a way to store data securely and is reversible, i.e. you can recover the data again after it's been encrypted, while hashing is a way to validate or get a signature of data and is not generally reversible. Anyway, having reiterated that, onwards. A good example of the application of cryptographic hashing is conventional logins using usernames and passwords. I imagine many of you have seen and probably used this, but ever wondered what's going on in the background? Let's start at the beginning. So you enter your username or email, i.e. an identifier that is unique to you, and your password, and you click the login button. The steps that follow this are usually hidden to most people. Your identifier and password are sent obviously over, well, maybe not obviously, over an encrypted connection to the server that is hosting the website that you're trying to log into, and then the real fun kicks off. You might think that the server would just compare your password with the one that it has stored, and while this would work, it is far from optimal for security. The major issue here is if the server you are trying to log into is compromised and someone obtains the passwords. This would allow them to log into your account and any other account you've used the same password for, which, by the way, you shouldn't have. But to counteract this, a properly configured server should only store the hash of your password hashed with a cryptographic hash function. This works because of a specific feature of a cryptographic hash function, which is that they are irreversible. What this means is that you can't work out what the input was that was used to generate the hash, at least not practically with current known technology and techniques. The technical name for this resistance is, the technical name for this feature, I should say, is pre-image resistance, if you're interested in the technicalities. So the server uses this hash function in the login process, and the steps that are followed are, it takes the password, puts it through the hash function, takes that hash and then compares it to the hash that's stored on the server. This means that the password is always the input, and so if someone steals the hash from the server, it's useless, as if you feed it back to the server, it will hash the hash, and that will produce a different result. For those of you who want technicalities, again, this is called second pre-image resistance. Unfortunately, this still is not optimal, and still vulnerable to certain attacks like dictionary attacks and attacks using rainbow tables. If the hacker gains access to hashes of from some website that you visit, they will try a few things. The simplest thing they can try is a brute force attack, which is where they just randomly try passwords and hash them to try and find a match. Another thing they might try, and slightly more sophisticated, is a dictionary attack, which is the simpler of the two I mentioned before. It's still a brute force attack, but it's where the attacker takes a large list of passwords that are known to be commonly used and hashes them and compares them with the hashes they have stolen. If there are any matches, then the hacker knows the password and can log into that account, or in many cases multiple accounts because people aren't very good with security. Another common thing they may try is a rainbow table attack. The maths and theory of this I'm not going to go into right now, they're too complex for the scope of this, but it's a much more advanced method than a dictionary attack, and much faster at finding the password that produces a specific hash. So what can we do about it? The easiest way we can defend against these attacks is something called salting. It's not a perfect and impenetrable defense, but it really helps a lot. Password salting is where before you generate the hash of a password, you add a salt to it, and the salt is just a random meaningless string of characters, and it's different for every user. This salt is also stored alongside the hash of the password and added every time the password is hashed. This eliminates the one-to-one relationship between the password and the hash. Because the salt is different for every user, the input to the hash function is also different for every user. This means that even if the hacker manages to work out the password for one user, they can no longer use it for another user with the same hash. And also, if the user has used poor practice and used a common or weak password, it mitigates the effect of a dictionary attack. Anyway, coming back from that long tangent, let's summarize what makes a good cryptographic hash function and why. Firstly, a good cryptographic hash function is a one-way function. That is, you can't work backwards from the output to get the input. This is important, and for a fairly obvious reason that we just looked at. Basically, if it's not one way, then someone can work out the input and use it nefariously. An example of this is logging in as someone else and stealing their data and/or causing damage. Secondly, cryptographic hash functions should also be very collision resistant. I talked about this last time, but to refresh, a collision is where two inputs to a hash function produce the same hash. This is important for security because it prevents attackers from just finding a different password that produces the same hash. There are also other attacks in other areas where cryptographic hash functions are used that collision resistance helps with. There are many other small factors that make a good cryptographic hash design, but I'm not going to talk about them now, so that's a wrap, and see you on the next one.